from group number 1, and this is our molecule. So let's try and identify the functional groups here. So what could this be? It's a ether. How about this one? It's a alkene. This one? An ester. How about these three? They are ketones. How about these two? They are benzene. And lastly, this one. This one's an alcohol group. Here's the full map of everything and all the functional groups that we have found. But how do I know what is what, and how can I identify these? First of all, let's talk about ethers. Ethers are easy to recognize as it's an oxygen in the middle of two R groups. The R groups are often carbon. Next, we have a hydrocarbon, alkene. So carbons here are linked with a double bond, as you can see in the example. So this makes it stronger than a regular bond, but not as strong as an alkyne, which is a triple bond. Here the name ends in ene, which is another way to identify an alkene just based on the name, like in ethylene.
This is methyl acetate, which is an ester. An ester is defined by a carboxyl group bonding to an alkoxyl group. They are created by reactions between a carboxylic acid and an alcohol. In this case, it's an acetic acid and methanol. So you can find an ester in perfume and fruits. It gives them a certain smell depending on the specific ester. For example, methyl acetate had a fruity group scent. So the general structure for an ester is RCOOR palm, while this one is particular is CH3COOCH3. Alright, let's talk about a ketone group first. A ketone has the basic structure RCOR palm, where a carbon atom is double bonded to an oxygen atom and single bonded to two other carbon groups. You can commonly find ketone in everyday substances like acetone, sex hormone such as progesterone, and even in some painkillers. Now for the main feature of ketones. First of all, a ketone is polar, which means it can dissolve in water to some extent. It also reacts well in chemical reactions, especially nucleophilic additions, and even though it is not strongly acidic or basic, it can still take part in redox and condensation reactions.
Okay, so I'm gonna talk about the benzene ring. This is basic structure, 6-member ring with alternating single and double bonds, commonly found in the compound like benzene, like aspirin and phenol. It's very stable due to aromaticity and prefers substitution react over addition reaction. So number 4, alcohol. Basic structure is ROH, commonly found in ethanol in the alcoholic drink, and methanol some like medicines. Polar, so mix well with in water, and can act at a weak acid. It can take part in the reaction like oxidation.